Hi guys, we are back with another content, and today we will be discussing about the Booth's algorithm. And Booth's algorithm is basically used for the multiplication of signed numbers, well, unsigned numbers in few cases as well. So with the help of Booth's algorithm, we need to compute the multiplication of two signed numbers. It would be a multiplication of S1 and S2, and we do this with the help of some arithmetic operations and some set operations. Well, in this case, we basically do this with the help of addition with a 2's complement of a number followed by an arithmetic right shift. So we will take a look at the addition of 2's complement number and right shift as well. But before that, we will discuss about some terminologies which are required before we head into the actual algorithm. So let's move ahead and discuss some terminologies. Okay. And so now, as we said, we will be discussing about the terminologies and the notations involved in learning Booth's algorithm. So the first thing is we have is complete group of ones and partial group of ones. So what are these actually? So suppose we have a string or pattern or block of ones. Say we have 0 1 1 1 0 1 1 1 0 1 1, right? So as per the definition, if we have a string of ones or a pattern of ones, and if we have a 0 to its immediate left of the block of 1, then we count this as a complete group. Okay, and so it could be even a 1 0 0 1 0. So this itself constitutes a complete block of 1. So it's a complete group. Whereas for partial group, we do not have any 1 to its immediate left. So say for this we have one block of 1. This is the another block. This is just another block, and suppose we have few more strings of ones, right? So this also makes another block, right? So we have 4 blocks, say 1 2 3 4, right? So we have a 0 to its immediate left, so it's a complete group. Again we have a 0 to its immediate left, so it's a complete group. Again for the same, these are the complete groups. But in this case, in the first one, we do not have any 0 to its immediate left. So this would be counted as a partial group. Basically, if you have any string of numbers, say 0 1 0 1 0 1 1 and 1. So we will count this as a complete group. This is a complete group, and this we count as a partial group. So if we have a string of ones followed by a 0 to its immediate left, it is counted as a complete group. And if we do not have any 0 to its immediate left, we count it as a partial group. So I hope this is clear to you. So let's take one more example for your better understanding, right? So I'll just clean this off. Yeah, so I'll just add another string, anything, say 0 1 1 0 1 1 0 1 1 0 1, right? This seems good. So look at the block of ones we have. This one, which is just a single one, could be counted as a complete group because we have a 0 to its left. Again, this would be counted as a complete group because we have a 0 to its left. So we have 2 groups so far. We have this block of ones and a 0 to its immediate left, so this is a complete, and this to its left, so we have a complete. So in this example we are having 4 sets of complete groups. Let's take another example for you, and say we have 1 1 1 0 1 1 1 1 0 1, right? I hope this is visible. So we have just a single block, so this is a complete group. We have another block of 4 ones, and to its left we are having zeros, so this is also complete. So these two are complete. And look at this case. So we have a block of ones, but we do not have a 0 to its immediate left. So as per the rules, we do not have a 0 to its immediate left. That's the best way to remember the partial and complete groups, because we usually get confused. So if we do not have a 0 to its immediate left, well, it's a partial group. Right. So now I think we have a better understanding of the terminologies related with Booth's algorithm, that is the complete group and the partial group. Right. So let's move ahead and see why do we need these complete and partial groups at all, and let's move ahead. Okay. So now that we know notations about the terminology and stuff, so let's take a look at why we need this complete and partial groups at all. So with the help of these partial and complete groups, we can reduce the number of operations that we need for a given string of number. So let's take a look. For here we have some examples which are basically string of zeros and ones. Again, we are taking just 4 examples for you. And here in this table we have complete groups and some partial groups, which contains the set of operations undergoing each set of ones. So we have one addition and one subtraction for a complete group. We have 0 addition and 1 subtraction for a partial group. Hope we are on the same page. And in this table we will have the total number of operations that we need to undergo for each set of strings. Right. So let's take a look at this string and see how many complete and partial groups we have, and with respect to that we will see what are the operations we need to take and the total number of operations involved in this computation. Okay, so let's take a look. So this is a block of 1, right? So we have one block and we have a 0 to its immediate left. So this is a complete group. This one is C. Again, we have another block of ones and we have another 0 to its left. So this is another complete group. Right. So we have 2 complete groups. Just write it down so we don't forget. So we have 2 complete groups, and for complete groups we need an addition and a subtraction. Right. So 1 addition, 1 subtraction for the first one. And since we do not have any partial group, so we will totally neglect this table for this one. And so we have 2 complete groups. So 2 complete groups with the addition and with subtraction. So we totally have 2 addition and 2 subtractions, right? So we have 2 additions and 2 subtractions, right? So I hope this is clear. In case you still have any doubts, we have plenty more options. So let's move ahead. So here we see occurrence of ones in a block. Sorry. So the occurrence of ones in a block, and as we can see, we have an immediate left to the block of ones. Right? It doesn't matter how many ones we have in this block. Even if it's just a single presence of 1, it would be still counted as a complete group. Right. So we have just a simple 1 complete group in this option. So we will have just 1 addition, 1 subtraction as per the standard rules. So we have 1 addition and 1 subtraction. So we will have 1 addition and 1 subtraction for the second example, right? So hope this is clear. Let's take a look and discuss these 2 options as well. So for this, as we can see, this is the block of ones. I know this is not tidy, still doesn't matter, just for your understanding. So we do not have any 0 to its immediate left. So if it's not any 0 to its immediate left, what it could be? Basic partial, right? So this is a partial group, and for partial groups we do not have any addition, right? So we do not have any operations for this complete group because there isn't one. So we have one partial, so we have one subtraction, right? So altogether we do not have any addition in the third option, and we do have one subtraction. Simple. Let's move to the next one. So we have a block of ones over here, and we have a 0 to its left. So this is one complete group. This is an interesting example. And again we have another block of ones, but we do not have any 0 to its immediate left. So what it could be? Obviously it could be a partial, right? So we have a complete group followed by a partial group, right? So what are the total number of operations we need for the particular group? So for a simple complete group we need one addition and one subtraction, and for a partial group we need just a subtraction, right? So we have one complete group, one partial group, and one complete group. So this will contain one subtraction, one addition, one subtraction. So we total have one addition and two subtractions, because we have an additional subtraction group from the partial group. So these are the basics of the partial groups and complete groups. We'll move ahead and discuss more about the actual algorithm, and we'll discuss about the Booth's pattern, Booth's encoding or Booth string, whatever we call it. Let's move ahead.